All right, let's give ourselves a function to work with here. So let's consider the function f of x is equal to 1/2 x cubed plus 3x minus 4. Now then, if g and f are inverses, or another way to think about that, here's f. We have a function g that exists, and it's the inverse function of f. And let's also give ourselves the statement f of -2 is equal to -14. And that's true. If you substitute -2 into this function, you get -14 as the output. Then what we want to find is we want to find g prime of -14. So take a look at what we've got here. We've got a function f of x, and we know that g is its inverse. We know that this point exists for f of x, and we want to find the derivative of g evaluated at -14. Keep in mind, we don't even know what g of x is other than it's the inverse of f of x. But if we take a look at the formula that we came up with in our previous video, we know that g prime of -14 is equal to 1 over f prime of g of -14. So I can figure out what g of -14 is and substitute that into the derivative of f, which I can find pretty easily. So let's start off with a couple of things that we need to know, and my advice for you is to work inside out whenever you're dealing with this situation. So I need to know what g of -14 is. Well, again, I don't know anything about g other than it's the inverse of f. So let's talk about this point right here, because we do have -14 kind of staring at us. If f of -2 is -14, if f of -2 is -14, then because f and g are inverses, remember that means that their domains and their ranges are swapped. So if this is true, then that also means g of -14 is equal to -2. Here's your input and your output. If they're inverses, it's swapped. So input of -14 for g is -2. So this piece right here is equal to -2. So I'm now looking at 1 over f prime of -2. Well, I can figure out what f prime of -2 is. Here's f of x. So f of x is 1/2 x cubed plus 3x minus 4. That means that f prime of x is equal to, just using my basic derivative rules, that's going to be 3/2 x squared plus 3. And so if I want to evaluate it now at -2, f prime of -2 is 3/2 times -2 squared plus 3. That's 4. That becomes 6 plus 3 is 9. So we can finally say g prime of -14 is equal to 1 over 9. And again, we didn't even have to find what g of x or g prime of x were. We were just able to use the formula that we derived in the previous video and come up with what it was equal to. All right, let's also take a look at a situation where we're given a table. So let's consider the table values. Let's consider the table values for g, h, and h prime, where the functions g and h are inverse functions of each other. And what I want to do is I want to find g prime of 0. And notice that g prime is the one thing that's not going to be on that table. We're going to have values for g, h, and the derivative of h, but we don't have anything for the derivative of g. But we're going to use the fact that they're inverses to come up with what g prime of 0 is. So as we build our table, again, we have x, we have g of x, we have h of x, and we have h prime of x. And if I just make my table really quickly here, for the values of x, we're going to look at -2. G of -2 is 7, h of -2 is 0, and h prime of -2 is -1. And then we're also going to look at when x is 0, and we're going to get -2 for g of x, 5 for h, and 3 for h prime. So let's apply our formula. We know that g prime of 0 is equal to 1 over, because g and h are inverses, I can look at h prime taken at g of 0. And then again, as I said in the previous example, work inside out. Start off with you need to know what g of 0 is. Here's 0, g of 0 is negative 2. So g prime is now 1 over h prime of negative 2. Okay, so now I need to know what h prime of negative 2 is. Here's negative 2, h prime is negative 1. So this is 1 over negative 1 or negative 1. Again, if you'll work inside out, follow your notation, you'll be able to evaluate the derivative of a function's inverse at a given point.